Hi, welcome to Physics 3.3 on calculating force. Force, remember, equals mass times acceleration. Force is directly proportional to mass and to acceleration, but mass is inversely or indirectly proportional to acceleration. For a given mass, if the F net, that means the net force, doubles, triples, etc., so would the acceleration. If the mass were to double or triple, the acceleration would be cut in half or by thirds. The F net and the acceleration always point in the same direction. Weight, remember, mass is the amount of matter an object takes up and is measured in kilograms and does not change when the object is moved from location to location with different gravitational field strengths. Weight, or Fg, is the mass of an object times the acceleration due to gravity. All forces, though, are measured in newtons. And remember that 1 newton is equal to the amount of force necessary to move 1 kilogram at 1 meter per second per second. Net force occurs when forces act in the same line or parallel to each other. We just add or subtract their magnitudes to find the net force, or the sigma F, the sum of forces. So in this example, you would have a net force of 27 newtons to the right, because 42 minus 15 would be 27. Then, being able to calculate the acceleration from that, acceleration is force divided by mass, 27 divided by 2 would be 13.5 meters per second per second. Other locations. A spring scale on a given planet reads 12 newtons. The balance shows a mass of 1.09 kilograms. What is the acceleration due to gravity on this planet, and what planet are you on? Well, since the force is given by 12 newtons and the mass by 1.09 kilograms, you have an acceleration of 11 meters per second per second. You are on Neptune. Example 1. 3 people are pulling a wagon applying forces of 100 newtons, 150 newtons to the left, and 200 newtons to the right. The wagon itself has a mass of 25 kilograms. Determine the acceleration and the direction the wagon would move. So the net force would be 50 newtons to the left, because 250 minus 200 would be 50. The acceleration then would be 50 divided by 25, or force divided by mass, giving an acceleration of 2 meters per second per second. Bonus, how fast is the wagon moving after 15 seconds? Well, remember, kinematic 1, V is equal to V naught plus AT. V naught was 0, acceleration was 2, and time was 15, giving our final velocity of 30 meters per second. Example 2. An airplane needs to accelerate at 5 meters per second to reach takeoff speed before reaching the end of the runway. The mass of the plane is 5,000 kilograms. How much force is necessary from the engine? Well, again, force equals mass times acceleration. You would need 25,000 newtons of force in order to take off. Bonus, how long is the runway if takeoff took 14 seconds? Remember kinematic 2, x is equal to x naught plus v naught t plus 1/2 at squared. Solving that gives you a horizontal distance of 490 meters. Equilibrium. Equilibrium is the condition of zero acceleration. In equilibrium, all forces cancel each other out, leaving a net force of 0. Objects that are standing still are in equilibrium because their acceleration is 0, and objects moving at a constant speed and direction are also in equilibrium. A woman is holding 2 dogs on a leash. If each dog pulls with force of 80 newtons, how much force does the woman have to exert to keep the dogs from moving? That should be 160 newtons in the opposite direction to keep the dogs from moving. Other locations. A brick requires 4,116 newtons to lift it on the earth. How much force would it require to lift it on the Sun, where the gravitational field strength is 274 meters per second per second? Well, on Earth, F equals ma, solving for the mass, we would get 420 kilograms. Placing that same object on the Sun, 420 times 274 gives us a force on the Sun of 115,080 newtons. Thanks for watching.